So section 11.2, chi-square goodness of fit test. So our last hypothesis test for the semester. So in the probability unit, you calculated probabilities using both experimental and theoretical methods. So there are times when it's important to determine how well the experimental values, so these are the ones we got from just doing the experiment a large number of times and hoping that the law of large numbers really works and gives us a pretty good idea about what the theoretical probability was. An example of this is if you wish to verify if a die is fair. So to determine if observed values fit the expected values, you want to see if the difference between observed and expected is large enough to say that the test statistic is unlikely to happen if you assume that the observed values fit the expected ones. Okay, so in this case, we're also going to be looking at observed counts and expected frequencies, just like we did with the chi-square independence test in the last section. And so our test statistic in this case is also going to be the chi-square test statistic. All right, so once again, we're going to have a hypothesis test where it's going to be phantoms minus the p, because there isn't going to be a population parameter here, which means in the hypothesis there's not a population parameter either. So these are also just going to be all words. So in this case, we're going to say that the data are consistent with some specific distribution that's stated in the problem, and the alternative is just going to say that they're not. So it's inconsistent with whatever distribution has been specified. And we're also, again, state our value of alpha. We're going to check our assumptions, which is going to be the same assumptions that we had in the last one. In this case, we're going to have a list to check, though, instead of a matrix for these expected frequencies. We're going to name the test we're going to do. So again, the chi-square goodness of fit test. To get that test statistic, chi-square, we can use one of our two forms of technology. So one, we're going to push, if we're using the TI-84, we would push stat 1 and we get into the list menu. We would put the observed frequencies in list 1, and we're going to compute a set of expected frequencies that then we will put in L2. To get what we expect in each of those categories, we're going to take the sample size times the proportion that we expected in that category, and those proportions will be given in the problem. Once we've got those two lists of data in there, we're going to push stat and arrow over to the test menu, scroll down to find the chi-square goodness of fit test, highlight next to it, and push enter. Now, in this case, we are going to have to enter a number for degrees of freedom. So in this place where it says DF, we're going to take the number of categories and subtract 1. Okay. So if I gave out some survey question that asked people what their marital status was, and if some of those choices, let's say we had single, married, divorced, separated, other, or something like that, so we've got 5 categories, then the number we would put here next to degrees of freedom would be 4, because it would be number of categories minus 1. And then we'll hit calculate, and on that output screen, we're going to see our test statistic, we're going to see our p-value, and then again, degrees of freedom, we're not going to worry about with table values. Again, it is important here on the input screen to get the right value there. And then this last piece in here, how much contributions each of those cells gives, that goes beyond the level of this course. So we're just going to also ignore this line on the calculator as well. So the only two things that we need are the top 2 lines of that output.